What's going on here. Now, on these little simple note cards here, what we're going to be looking at now is some polynomial with some m degree divided by some polynomial with some nth degree. And this is what our function is going to be. Okay? So, what's going to happen now is that we're going to be able to take basically 3 steps to determine x-intercepts, vertical asymptotes, and horizontal asymptotes. Okay? Now, what I want you to keep in mind is that the numerator is going to be our mth degree, and our denominator will be the nth degree. That's how we determine what's going on. So you get these different cases. So the first thing that we want to do is we're always going to try to identify the x-intercepts. Yeah. The first thing we're going to do is we're always going to identify the x-intercepts. The x-intercepts will always be the real zeros of the numerator. So I put zeros in parentheses, which means that you might have to factor the numerator. It could be a quadratic, it could be a quartic, it could be any of those. You can have multiple zeros. It could just be 1 0. You don't know. Depends upon the problem. So the first thing you wind up with is finding your x-intercepts. We've been doing that a lot. We did that with polynomials, so we know how to do this. It's not factoring this stuff through isn't going to be that big of an issue. This should be pretty easy for us. The second thing we do is then we identify where the vertical asymptotes are. The vertical asymptotes are still at the zeros, in parentheses, of the denominator. Very, very similar to what you did yesterday. In fact, it's the exact same thing as you did yesterday. Once you found the zeros of the denominator, you put dotted lines vertically.
Is there any difference in that we have to identify the x-intercepts?
Yeah.
Okay.
And now, I shouldn't say the only difference, because there is one other subtle difference, is in how you determine where your horizontal asymptote is going to be located. You have then 3 different scenarios to check for where your horizontal asymptotes are going to go. Okay? And it depends upon the degree of the polynomials. Depends upon the degree of the numerator and the denominator. Your numerator could be greater than the denominator, they could be the same, or the numerator could be smaller than the denominator. One of those 3 things will exist, which means one of these 3 different asymptotes would exist. And that's kind of what I wrote out there on that little sheet about the m's and n's being greater than and less than or equal to. So the third thing is the horizontal asymptote case. What was the first one I wrote down? M is less than n, I believe?
Yeah.
So if the degree of the numerator is smaller than the degree of the denominator, your asymptote is
0.
Y equals 0 is our asymptote. It's pretty easy. So basically that means if you have 2x squared plus 4 over x cubed minus 17, it means you have a horizontal asymptote at 0. That's all. You're just looking at the degrees of the polynomials. Okay? The second case was, I think, if they were equal.
No.
Oh, greater than was the second one?
Yeah,
Okay.
that's greater than n.
So if the top is greater than the bottom, then you had no asymptote. You have no vertical asymptote. You will have a slant asymptote. Okay, we'll show you how to do that in a bit here too. It's really easy to find. And then the last one is if they are equal. And that one pairs back to what you did yesterday. Remember when you had the ax plus b, cx plus d on the bottom? They had the same degree, didn't they? The asymptote was the coefficients. Same deal here with higher degree polynomial. Same thing. If the two degrees are the same, if the degrees of the polynomials are the same, your asymptotes can be at y equals that leading coefficient a over b. Exactly like it was yesterday. Yes, ma'am.
Wait, so if n is greater than n, there's no vertical asymptote?
Did I write vertical? I'm sorry. I meant horizontal. I'm sorry. Thank you for catching that. I was talking all about the horizontal stuff. Okay. So just a refresher here. If this looked like that's a case of what it would look like if the numerator had a smaller degree than the denominator. That just means that you have a horizontal asymptote at y equals 0. Okay? If the top was bigger than the bottom, it would look like that. Pretty obvious. Bigger degree on the top than there is on the bottom. And if they were the same degree, it's going to look exactly like what you had yesterday. That's kind of what I've made up as far as that little blueprint of that little sheet just to put in your notes. So I thought it was easier to have that sheet there and then kind of like reword it in your own way if you wanted to, as opposed to trying to just have you write it all out at the same time. Okay. Now, what happens then is that within these three different cases, what we're going to kind of do today is get the rough idea of how in the world do you start the problem, how do you set it up, and then build our asymptotes. And once we start learning how to build the asymptotes, then we'll start worrying about how do I decide what values I'm going to pick for numbers to see what these graphs are going to look like. Okay? Because that can get a little bit tricky because there's a case here where sometimes you might not have a vertical asymptote. You might not have a 0 in the denominator where you would have a continuous function, but yet you don't know how to graph that. You don't know where to pick values. Sometimes it might be off what it would normally look like. So what we try to do is just kind of build it up a little bit slowly. So let's do an example. Do you need more graph paper? I've got more before I forget. Let me send some more around. Will you guys pass those guys some papers when you get back to them, please? And send some to the children. Feed them well. Let them lead the way. Show them all the beauty they possess inside. Give them a sense of pride, make it easier. Yes, ma'am. Oh, did you just sketch it and just put your ordered pairs? That's fine. That's fine. Sometimes with these things, it's easier for people to start with their vertical asymptotes on the graphs because then you know exactly where things are going to get placed through. That's all. But if you didn't put freaking, I'm not kidding. All right, which one was it? No. All right. I wrote it down and I left it in my own. All right, let's do this one. Let's do this one. Y equals 4 over x squared plus 1. And let's go through the whole process of each step. Okay? All right, so now let's go off what we know. First thing, x-intercepts. Is there a 0 for the numerator? No. Is there an x-intercept? No. There's no 0, so there's no x-intercept. Right, because there's none. Okay. Is there a real 0 of the denominator?
Yes.
So our vertical asymptote? I would subtract 1 and take the square root, and I'd have imaginary roots. So I'd have imaginary roots, but they're not real, so I have vertical asymptotes? No. Where is the degree greater, the top or the bottom? The bottom. So that means my m is less than my n. So where's my horizontal asymptote? It's 0. Now I have enough information to start this graph. I have no vertical asymptote, I have no x-intercepts, but I have a horizontal asymptote at y equals 0. Now yesterday I asked you guys to pick values in your domain that would bound on either side of a vertical asymptote because those were easy to pick with. Now, I'm just going to, what?
Why is there no vertical asymptote?
Is there a real 0 for the denominator? No, it's imaginary. You can think about it, you just can't graph it.
Wait, what?
Yes, sir.
Wait, if the y value is equal to 0, why is it running along the x-axis?
Because if it's running along the x-axis, that y value.
That was actually a really dumb question.
No, it's not. It's y equals a number is always horizontal. X equals a number is always vertical.
There's only one small question.
It's the one not asked.
No, it's the one others.
Missed it. What was it? I forget that. Isn't that Christian Slater? Yeah.
No,
He's a radio DJ.
no, that was public volume. That's a really good movie. Watched that the other night.
Now think back to graphing linear equations. Now's the time when I'm just going to look at it around the x-axis. I'm going to go -2, -1, 0, 1, and 2, just to pick numbers and see what's going on with it. Okay.
I thought we only did something yesterday if it was like A or C.
But here's the problem. This is different. This is a different case. So I'm showing you different cases. Bless you. Our function was 4 over x squared plus 1.
Yes.
What's -2 squared? What's 4 plus 1? So at -2, it's at 4/5. What's -1 squared? What's 1 plus 1? What's 4 divided by 2? What's 0 squared? What's 0 plus 1? What's 4 divided by 1? And gee, what happens going back down the other side? It comes right back down. So this graph does this. And it's approaching the values of 0. It's just going to get infinitely closer and closer and closer to it, but never cross it because there's no x-intercepts. And that's why it's bound by you have that horizontal asymptote. Yes, sir?
It's a hill.
Yes. So our domain, is there any restriction among our domain? No. In this case, there is absolutely no domain restriction. So my domain is all real. My range, now my range is bound by 0. You okay with that? Yes, ma'am.
Can't the domain not be 0?
If it's 0, what's 0 squared?
Oh,
You see, what happens here, Levon, is that since there's no vertical asymptote, there's nothing to stop it from being there. But here, my range is going to be all y values, and see how the graph is never going to be below that? So it'll be all y values that are greater than 0. This case has a boundary to it where it's greater than, because it's above it. There is no above and below in this case. It's not like those hyperbolas we had yesterday. Okay, that's why it's a little bit different.
So this style is always going to be a little.
It could be. There's going to be subtle variances in all of these, depending upon the type of problem. I'm only going to have time today to probably show you about maybe 2.5. Okay? Yeah?
Would the range also be below 4?
Yeah, yeah. So I can, yes, you're right. It's bound by 4. So it's greater than 0, but, so let's see. We'll say y is greater than 0. Does it ever equal 4?
Yes.
But less than or equal to 4.
Do we have to add them in, or is it just like something they
This is kind of a weird one. It doesn't, this isn't always there, but yes, that is technically the right way to write it.
Okay.
You can write it's greater than 0, you can write it's less than or equal to 4. You don't have to put this into compound if you don't want. Sorry?
Where did you get what the range was? Like, why is it greater than?
The range is your possible y values. It goes up to 4, and then it comes back down.
Okay, so it's,
Okay.
wait, would the graph just be, would it just flat line like that?
Yeah. Yeah.
Why does it have to be more than 0?
Is it ever going to pass 0? Since there's an asymptote here, it's going to get infinitely closer and closer and closer to it. It's like the idea, I'm not touching you, I'm not touching you, I'm not touching you. But in theory, couldn't I just continually fold paper in half?
No. It stops at 7.
Yeah.
You can only fold it 7 times.
Then you'll always win. Exactly.
How do you know that?
All right, let's try another one.
You get to say that word.
Let's try another one. So I have y equals x squared plus 4x minus 5 over x minus 6. You do the kind of the same setup. When you start these problems, keep in mind the 3 things you're looking for. X-intercept, vertical asymptote, horizontal asymptote. So since the polynomial on the top, if you find those zeros first, the first step would be to find the x-intercepts. So you look for the x-intercepts of x squared plus 4x minus 5. You set it equal to 0, and you factor it. So, what times what is negative 5? You add together to get 4. 5 and negative 1. So your x-intercepts will be at negative 5 and 1. Okay.
Why does x-intercept matter?
Yes. Vertical asymptote. Second step. The vertical asymptote is always located at a 0 of a denominator. What's the 0 of this denominator? There's your vertical asymptote. So, thirdly, we check our degrees. The degree of the top is 2, the degree of the bottom is 1. So this is the case where m is greater than n. Is there a horizontal asymptote? No. There's no horizontal asymptote. What there is a slant asymptote.
Are we learning how to graph these?
Oh yeah. Okay.
Oh, is that going to tie into the x-intercept?
Yeah. Yep. It all ties together. All right. So now you start looking at the information you have. You just start plotting what you know. You've got two zeros, -5 and 1. And you have a vertical asymptote at 6. Okay? Now, unfortunately, this one is really difficult to kind of plug and chug your way through. So what I'd like you to do is use your calculator real quick, and I want to show you how we can do this with a table. Okay? Oh, I'll show you tricks on how to do it without a calculator. But I just want to get you see what it's doing so you can get the idea of what values you would pick through. Because when you have this case of the m is greater than n, you get this slant asymptote. And I'm going to show you how it looks like on this graph, so that way when you see this come up again, you know how to find that asymptote, then you know how to pick values. Because just like yesterday, how we were bound by that vertical asymptote, you had numbers on both sides. If you know where the slant asymptote is, you can pick an ordered pair. So it seems like it's really, really, really weird. But once I show you how it works, you're like, oh, that's why you taught us how to do that. Because there's a reason why I showed you guys how to do certain things. And then you'll do this again later. There's a method to my madness, believe it or not. So first things first, we throw that in our calculator, which alpha y equals, you know the shortcut keys, right? The alpha y equals? Shortcut keys. If you hit alpha y equals, and after you go to your graph, when you hit the y equals button, you hit alpha y equals, it comes up with the shortcut for making a fraction bar on those. Hit y equals. No, I never drop this. I'm always flipping this thing around. I can never drop it. The first time I dropped it, like a long time. Drops. So your window right now is probably a regular 10 by 10, right? If you hit the graph button, thank you for showing her. If you hit the graph button, you just see this portion. If you're on a 10 by 10 screen, right? Now, what's happening though is that I want you to realize, since there's that vertical asymptote at 6, there should be something else going on to the right of it. So that means we need to adjust our window a little bit to see what in the world's going on. So what we need to do is figure out, where should I move it to? So here, let's hit second table, and let's just start looking at numbers. If I go back and I look at my table and I start at -2, we know that we had a 0 at -5, if I'm looking at my table. At -4, it moved up. At -3, it moved up a little bit more. It moved up a little bit more, and then it came back down. So it did this. It came and hooked, and then it approaches the asymptote. It's a hyperbola, even more slantified. It's more slantified hyperbola. Okay? Now, on the other side, it's doing the same thing, but as you go through your table, as you get past 6, here's my other 0 at 1. As you get past 6, you'll see how it goes error at 6. That means it's vertical. But look where your next valid point is at. It's at 7 and 72. Why? Because when you substitute in 7, you get 72 for y. So 72 is right there. I know, because it did second hour. This isn't real. Take that. So what happens is there's another curve way up there that's looping itself around. So look at your window. Change your x maximum to be 50. 100 works, whatever. Change your y maximum to be 100. And now look at your graph. What's happening is that on the other side of the graph, you have this here, and you have this here.
Why do they show like half of it on one side of the table and half of it on the other side?
Because isn't half on one side of the table and the other half would be on the other side of the asymptote?
Yes, I don't know.
Here's what's happening, is that there's a slant asymptote that occurs when you have an m greater than an n. So, how do you find the equation of said slant asymptote? Well, back in polynomials, you guys did a little something called long division. You also did a little something called synthetic division.
Oh, yay!
Yeah. Watch what happens. Watch what happens. Shh. Hold on. Watch this. If you take, what's the zero of the denominator? 6. Take the zero of the denominator, synthetically divide into your coefficients of the numerator. 1, 4, and -5. If you synthetically divide that, you get a 1, 6, 10, 60, and a -55. That means if I divide it out by my zero, my polynomial function would be x plus 10 minus the 55 over x minus 6. You okay with that? This is the remainder. This I don't care about. This is the equation of the slant asymptote. Go back to your y equals real quick and put in a second one,
That's weird.
x plus 10. Regraph it. There's your slant asymptote. That would have been awesome. That would have been awesome. No, but it wasn't this. That was the marker thing.
Wait, does it mean what? Does that mean that it's not supposed to like go over it?
What that means, Scott, is that curve, this curve is bound by, it's approaching this slant asymptote here as this one is coming around and approaching it that way.
On my graph, like they intersect.
It will look like it does, but technically it won't. It does. Then you, did you type in x plus 10? Okay. What happens here through this one? Oh, because you wrote x plus 1.
Oh.
You need a 0 after that. So
Oh, I thought I just knew like the.
there will be a time tomorrow when I show you guys these graph things that sometimes a curve can go through an asymptote because you can factor something out and you get a hole. We'll talk about that later. What's that? Yeah. It doesn't have any problem with it anyway, but yeah. Yeah, I added, but I don't know why I did that way. Okay? So, what's different is that I'd like you guys to find if you have an m greater than an n, I'd like you to write down what the equation of the slant asymptote is just by using synthetic division. As soon as you synthetically divide, you're going to get a linear equation for the first two. That's always the equation of the slant. Okay?
Can we use our calculator on the phone? Like just to check it?
Yeah, because I'm going to show you guys other tricks on how to do it without a calculator now. I just want to get you guys I'm not going to ask you guys to graph today. I'm going to ask you guys just to find all the parts. Get me zeros, get me asymptotes. That's what I'm looking to do today. Okay? Yes, ma'am.
How come if you put everything like by 1,000 for like X amount, how come it's like,
I don't know. My name is in Texas. Last name Instruments. Oh, math humor. All right. One more. We'll do this one real quick.
Yes,
For the one that we just did, like the x squared equals 4x minus 5 over x minus 6.
Yeah.
How do you find the ordered pairs?
What do you mean? Oh, it's nasty to be able to do that. We'll worry about showing you tricks on that tomorrow. For tonight, like I'm saying, I'm just giving you the idea of what the different cases look like today. Show you how to walk through all the asymptotes and things like that. Then we'll worry about how can you generate ordered pairs more so tomorrow. So don't worry about graphing perfectly today, okay? Yes, ma'am?
So what for the graphing, are they just supposed to like exactly
You're not even going to be graphing. You're just going to be writing down parts. Today I'm showing you what they are, so when we do it more tomorrow, it'll be easier. First thing, x-intercepts. So I have to find the zeros of the numerator. What times what is 30? You add together to get negative 13. Negative 3, negative 10. Then we group it. So I have 10/3 and 1. Okay. 10/3 is 3 1/3, right? So that's, if you do have to plot a third or any halvesies or quarters, that's not bad. You're just fudging it. It's not rocket science. We're not trying to go to the moon yet. You never know. It might be, we lost funding, yeah. The magic 8 ball wasn't working that day. So I have zeros at 10/3 and 1, so I have 1, 3-ish. Vertical asymptote be at the zeros of the denominator. Are there any real zeros of the denominator?
No.
No, because it's x squared. The square root of negative 8 is imaginary, so there aren't any. So there's no vertical asymptote. Here, the degrees are the same. Just like yesterday when the degrees were the same, what was your horizontal asymptote then? Yeah, it was just the coefficients. In this case, you have coefficients of 3 and 1. So your horizontal asymptote would be at y equals 3. Okay. Now, not having a domain restriction, could you pick, this one wouldn't be terrible to pick numbers, because the next number I would choose is 0. If I put 0 in for x, I get 0 minus 0 plus 10, and 0 plus 8. So I get 10 over 8. 10 over 8, couldn't get away from buffet. It never gets old.
Oh, took me a second.
10 over 8, ATE.
I got it now.
Oh, go back to the buffet. He's over 8. Really loses a lot. Was your math teacher this funny before? Oh, I got a tough act to follow. I'm a leader. So 10 over 8 is what? 5/4? 1 and change? I mean, you can, when you get to some of these, it does get kind of nasty to figure out ordered pairs. I just put in zeros. So it's, it's 5 over 4. 1 and 4 will be up here. I just put in 0. What's 0 minus 0? So I have 10 over 8. The whole back to the, oh man, I'm so over 8. 10. Get away from the buffet. What?
You just took it away? Why was 6 afraid of 7?
Because 7, 8, 9. If I'm not mistaken, I put the stuff on the calendar already.
Oh my goodness.
So we just leave it with the dots and the line?
Yeah. I'm not trying to, I don't want to get into the full-on graphics for tonight.
Heck yeah.
So this is 9.3 old book. All I want you guys to really kind of walk through tonight, if you want to plot them on a piece of graph paper, go for it, because we'll probably use some of these examples to show how to actually pick ordered pairs. It's not a bad idea, but I'm not looking for you guys to full-on graph them yet. So what I'm looking for you guys to be able to do is identify any and all x-intercepts, vertical and horizontal asymptotes. If you'd like to go ahead and plot them, please do, and then we'll just kind of build from there. I know I didn't say this, because we actually got a little bit further than second hour. If you do have a, I know it's weird. If we do get to the slant, if you guys do get to one where we'll have a slant asymptote where m is greater than, go ahead and write that down just so you get the habit of it, because I will ask you for that if it's necessary, okay?
Write the equation?
Yeah. Let's write the equation of it. In LeBlanc, you can see they're really quick to find. They're not tough. You actually use the slant asymptote a lot in pre-calc, so I might as well show you how to do it now. Yes, ma'am.
Okay, if you have x to the third minus x to the 7, 2 letters.
Yeah.
You wouldn't have to do the difference of
Right. Because if you go through it the other way and you do the difference, because if you go through difference in squares, your secondary zeros are going to be imaginary.
Then why do we learn difference of cubes?
Because if you had to factor it fully, you got to know how to do difference of cubes. But if you're just finding the zeros, you just set it equal to 0 and solve.